Solve the second order homogeneous linear differential equation with constant coefficient. This is the second order homogeneous differential equation given, and the initial conditions are given: y equal to e to the power 1 by 3 at x equal to 1 and y equal to 1 at x equal to 2. So given differential equation is 9 second derivative of y with respect to x minus 6 first derivative of y with respect to x plus y equal to 0, and the constant coefficients here are 9 and 6, and this is homogeneous because the right hand side you have 0. So suppose this is equation 1. To solve the given differential equation, let y equal to e to the power mx is the solution of the given differential equation. Then the value of first derivative of y with respect to x will be equal to m into e to the power mx. The second derivative of y with respect to x will be equal to m square e to the power mx. And if you put the value of first derivative of y with respect to x, second derivative of y with respect to x in equation 1, then what you will get? You see, the first term is 9 into second derivative of y with respect to x, that is equal to m square e to the power mx. So 9 into m square e to the power mx minus 6 into first derivative of y with respect to x, 6 into m into e to the power mx. So minus 6m e to the power mx and plus y value is equal to e to the power mx. So plus e to the power mx is equal to 0. And if you take common e to the power mx, you see, if you take common e to the power mx, in the bracket you have 9m square minus 6m plus 1, that is equal to 0. Suppose this is equation number 2. Remember, equation 2 is called auxiliary equation or characteristic equation, and if you solve equation 2, that is the auxiliary equation, then you can find out the roots of the equation. And in the auxiliary equation, which is quadratic, 9m square minus 6m plus 1 is equal to 0. So 9m square minus 3m plus 1 is equal to 0. If you take from these two terms 3m common, then you have 3m minus 1. If you take from these two terms minus 1, then the bracket you have 3m minus 1, that is equal to 0. So 3m minus 1 whole square is equal to 0. So 3m is equal to 1. So m will be equal to 1 by 3. So here you have only the two roots are equal. That is, in this quadratic equation you have two roots. Both the roots have equal value, that is equal to 1 by 3. And for equal roots, we know the solution of the second order differential equation y equal to c1x plus c2 into e to the power mx. And here m value we find 1 by 3. So y will be equal to c1x plus c2 e to the power x by 3. Suppose this is equation number 3. Now you put the initial conditions to find the value of c1 and c2. So the first initial condition is at x equal to 1, y value is equal to e to the power 1 by 3. So if you put x is equal to 1 here and 1 here, then the right hand side will be equal to c1 plus c2 e to the power 1 by 3. And in the left hand side you have y is equal to e to the power 1 by 3. So e to the power 1 by 3 is equal to c1 plus c2 into e to the power 1 by 3. So e to the power 1 by 3 cancels from both the sides. So c1 plus c2 will be equal to 1. Suppose this is equation number 4. And the second initial condition is at x equal to 2, y equal to 1. The given equation is y equal to c1x plus c2 e to the power x by 3. And if you put x equal to 2, this term will be equal to 2 into c1 plus c2 e to the power x value is 2, so 2 by 3. And y value is equal to 1, it is given. So 1 is equal to 2c1 plus c2 into e to the power 2 by 3. So what will be the value of 2c1 plus c2? That will be equal to e to the power minus 2 by 3. Suppose this is equation number 5. And from equation 4 we have got c1 plus c2 is equal to 1. And from equation 5 we have got minus, you see, 2c1 plus c2 is equal to e to the power minus 2 by 3. So if you subtract equation 2 from 1, then c2 cancels. c1 minus 2c1, that is equal to minus c1, that is equal to 1 minus e to the power minus 2 by 3. So c1 will be equal to e to the power minus 2 by 3 minus 1. And if you put the value of c1 here in this equation, that is equation 4, then you will get the value of c2. c2 will be equal to 1 minus c1. So 1 minus c1 value is equal to this. So 1 minus of e to the power 2 by 3 plus 1, that is equal to 1 plus 1 2. So 2 minus e to the power minus 2 by 3. So you have got two the two constants. One is c1 and another c2. And the equation is y equal to c1x plus c2 into e to the power x by 3. So if you put the value of c1 and c2 here, then you will get the required solution for the given differential equation. Thank you.